Alright, welcome back. In this fun-filled video, we're going to look specifically at half-angle identities and how to solve problems and find exact values using the idea behind the half-angle identity. Now, one thing you have to keep in mind is that most of the time what you are going to be given is the value for the half angle, which means you would have to be able to determine the original angle and the quadrant in which that you lie in. Now, with the half-angle identities, notice we've got the three of them here. And they look very similar, at least for sine and cosine, to the power-reducing identities. So do make sure that you do not get these confused. The way that I like to remember them is that my half-angle identities have square roots, whereas the power-reducing identities do not. Now, your tangent identity is going to have two choices, where you have sine over 1 plus the cosine, or you have 1 minus cosine over sine. So you have to be careful in choosing which identity you want to use. Okay? Now, the other thing is that you can always recall that the tangent is the same as sine over cosine. And so theoretically that always carries through. So that gives you an additional option to be able to work with. Now, like always, I find the easiest way to figure out these identities is to use an example. So I've got an example here. And this example says that you have to determine the exact value of the expression. And we're telling you the expression is 67.5 degrees. Well, one of the ways that I know that this is not what I want to work with is if I look at my unit circle, notice nowhere do I have 67.5 degrees. So I want to be able to use my half-angle identity to see if I can make something that works a little bit easier. So first and foremost, I have that x over 2 is equal to my 67.5 degrees. So with that, if I solve for x, I find out that x is going to be 135 degrees. Well, if I look at my unit circle one more time, notice I've got a 135 degree angle. It shows up here in quadrant 2 and it has two x values. So I can draw this triangle as reference. So I'm going to want to use my 135 degrees here. So I'm going to draw that reference triangle just so that I have it. It was here in quadrant 2. And so if I look at this as being the reference, this would be my reference angle here. And so notice, because it was 135, my reference angle is going to be the same as the 45 degree mark. So here, if I look, that means my radius here is 1. My x value is going to be negative square root of 2 over 2, and my y is going to be the positive square root of 2 over 2. So here is my reference triangle that's going to help me with my problem. So I have tangent. Okay, so this means my tangent, I have two choices, sine on the top or sine on the bottom. In this instance, let's go ahead and play around with sine on the top. So I'm going to use the sine of x all over 1 plus the cosine of x. So in this case, I have to plug it in. My x value is 135. So this is going to be the sine of 135 degrees over 1 plus the cosine of 135 degrees. Well, I've got my reference triangle here, so I can actually do the sine of 135. Remember, sine is opposite over hypotenuse, so this is going to end up being the square root of 2 over 2. And then this is going to be over 1. And I've got cosine, so cosine is adjacent, and my sine is negative, so this becomes negative square root 2 over 2. My fraction rules state that I have to combine my fraction in the bottom before I can worry about the top. So here, this is still going to be the square root of 2 over 2. But in the bottom, this is going to end up reducing to 2 minus the square root of 2. The whole thing is over 2. Now if you look, my denominators here are going to be the same. So what's going to happen is those are going to go away. So I'm going to shift over here, and what we're going to be left with is the square root of 2 on top, and then we're going to have 2 minus the square root 2 on the bottom. Well, we can't leave this denominator here. We have to rationalize. So you're going to multiply top and bottom by 2 plus the square root of 2 over 2 plus the square root of 2. Remember, that's called multiply by the conjugate. And when we actually multiply this out, what we're going to end up getting is we are going to be left with 2 square roots of 2 plus 2 all over 4 minus 2. So we have to reduce, and what we're going to end with is we are going to end with the square root of 2 plus 1. So what we just did here is we used that half angle to show that the tangent of 67.5 is equal to the square root of 2 plus 1. And this is the result that we were looking for. Alright, so now let's take a look at another one. So in this case here, I've got the sine of 5 pi over 12. So remember, we have x over 2 is equal to my 5 pi over 12. So we have to find what x is. So in this case, we're going to have that x is equal to 5 pi over 6. So we're going to do the same thing, but this time we have sine. And notice my term here is positive. So I am going to use the positive radical. So here I'm going to have the square root of 1 minus the cosine of x, and the whole thing is over 2. Well, I just found my x value to be 5 pi over 6. So this is going to be the square root of 1 minus the cosine of 5 pi over 6, the whole thing divided by 2. So just like before, we want to use your reference or your unit circle to try and see if you have 5 pi over 6. And if you look, we do. It's right here at this 150. So again, we are in the second quadrant, but my reference angle here will be the 30 degrees. So I can draw that angle here. So again, I'm in the second quadrant, so I'm going to go ahead and put it in there and drop it down. So this is going to be my reference angle, and my reference angle is 30 degrees. This makes my radius 1, and because my reference is 30 degrees, it makes my x value the negative square root 3 over 2, and my y value is 1/2. With that reference, I can plug in and reduce. So this is still going to be the square root, and I have 1. And then in this case, I have minus. So if you remember, we're doing cosine. Cosine is adjacent. So this is minus a negative becomes a plus. So this is the square root of 3 over 2. And the whole thing is over 2. I need to reduce as I go. So just like before, combine your fraction. I look at just the top, and this is going to be 2 plus the square root of 3 over 2 with the whole thing over 2. Keep the top and multiply by the reciprocal of the bottom. You end up with the square root of 2 plus root 3 all over 4. Now we know the square root of 4 reduces, and so this is actually going to be the square root of 2 plus square root of 3, and the whole thing is over 2. Okay? Again, this was the sine of 5 pi over 12. And here was what we are looking for. Okay? So this idea is very similar to the idea that we used with our normal trig identities, as well as some of the sum and difference identities. So again, what we're doing is we are looking for the exact values that we get out of these problems. So if you have any questions, please let me know. If you feel like you need to see an additional example that I did not provide, please send that to me and I would be more than happy to work it out for you. Otherwise, I do hope you enjoyed yourself, and I look forward to seeing you next time.